Hello, ladies and gentlemen. So here's an example of a question that's giving us a triangle. They're giving us some information about a triangle. First of all, they're going to tell us that one of the angles is 27 degrees. It's going to tell us that the side opposite that given angle is 25 centimeters. And it's giving you the side length of one of the other sides. The important thing to notice here is that what we have is three pieces of information. And we're going to assume that at least one triangle can be made, and we're going to go through the motions in trying to solve that triangle, which means that we're going to try to get all the interior angles, so we've got two other angles to get here, and one side. With this setup, what we're going to do is we're going to look at the sine law. The sine law was going to have us do sine of b over top of 30, so the sine of this angle divided by 30 is going to equal sine of 27 degrees over 25. So what's happening is this is the angle we want to get, and moving forward, this is the relationship that we set up. So this works out to give us sine b equals 30 sine 27 over 25. So grabbing a calculator and working through that, I'm going to have sine 27 equals times 30 equals divided by 25 equals, and it's approximately 0.5445 if I wanted to give it an estimate, a rounding. So it's going to be sine of b equals approximately 0.545. All right, so now that answer, using our second function inverse, putting that answer in, I'm going to get 33 degrees. So, using this sine inverse of 0.545, etc., we're actually going to get angle B equaling 33 degrees, approximately. Now, as we've discussed before, there's another possibility here. Also, angle B could equal 180 minus 33, which is going to be 147. So we have two answers for angle B. Once again, not wanting to go over the point too much, but where that 147 comes from is that if we have one answer for our sine is here at 33 degrees, our other answer is going to be over here where our rotational angle is going to be 180 minus the 33 that goes here. So it's going to be 180 minus 33, which is the 147 that we have here. I'm not going to have to draw this every time, but I certainly want you to understand where it's coming from. So these are our two possible answers for B. We have, looking for my pen, we have B could be 147, or B could be 33 degrees. That's this angle. So the question is, can only one work? Can both work? Do either work? So let's see. If angle B equals 33 degrees, then angle C would equal 180 minus the 27 minus the 33. And that'll give us 180 minus 27 equals minus 33 equals 120 degrees. Angle C will be 120 degrees. That makes a triangle. Yes, we have a triangle. Okay? Over here, if angle B equaled 147 degrees, then angle C would be 180 minus the 27 that we had here, it hasn't changed, minus the 147, so that'll be 180 minus 27 minus 147, and it leaves us with angle C equaling 6 degrees. So yes, another different triangle is possible. One of them will have angle B as 33 degrees and 120 degrees for angle C. The other one will have 147 degrees here and 6 degrees up here. So 147 here and 6 there. And notice that both triangles have the same information. Let me show you that. Let me grab a piece of paper. So what would happen here is you'd get two triangles. The first one would look something like this. Not drawn to scale, but you're going to get your 27 here. You're going to get your 30 here. You're going to get your 25 here. We'll still call this C. We'll still call this B. And the other one, well, let's finish this off. This would be 27. This would be 33. And this would be 120 degrees. Now notice it's not drawn to scale, but that's one of the triangles we've come up with. Let's come up with the other triangle. The other triangle is going to look more like this. This will still be A. This will be 27. This will still be B. This is 147 this time. And up here is going to be 6. So, well, if I use the same color scheme, that should be a red 6. That should be 147. This is still going to be 25. And this is still going to be 30. So notice that the information that was given, this, and this, are the same for both triangles. And yet I have two very different triangles there. The big difference between the angles is also going to be this side length C. This side length C, in the first triangle, we can use the sine law again. We can say that C over sine of 120 is going to equal 25 over top of sine of 27. That'll give you C equals 25 sine of 120 over top of sine of 270. Let's take a look. Is that focused? Let's see. There we go. So it's going to be 120. Oh, in this calculator I got to do sine first. Sine 120 equals times 25 equals divided by sine 27 equals, and C is approximately equal to, I don't know, let's call it 47.7 centimeters. And over here, the same calculation, the only difference is C will now be over sine of 6, because the angle opposite, it's only 6, equals 25 over sine of 27. So C will equal 25 sine of 6 divided by sine of 27. So sine of 6 equals times 25 equals divided by sine 27 equals, and we get C equals approximately 5.8 centimeters. So up here you've got 47.7 centimeters, and up here you've got 5.8 centimeters. Everything else stays the same, but you have two completely different triangles based on the exact same information, which is why we call this the ambiguous case. Ambiguous means unknown, questionable, not terribly sure. We don't know which one of these triangles they mean when they give us these three pieces of information. So your duty is to solve for both. Well, there you go. That's the end of this little example, and I'll come back in a minute.